All right, welcome back. So this is another ALEKS topic. This topic is called Identifying Precipitation, Combustion, and Acid-Base Reactions. This is a really nice topic to give us an introduction to looking at chemical reactions, starting to classify them, and trying to pick out what the important information is. So what's confusing, I think, about this topic is that it's check all that apply sort of situation, which looks more daunting and confusing than it actually is. So don't get too stressed out. So let's go ahead and get into it. I'm going to do two different examples of the same topic, so stick around for that. But the first one here, when I look at this reaction, I've got a solid, sodium solid, reacting with O2 gas to form this sodium oxide solid. This is what we call a combination reaction. These two things are combining to form one new product. So that's it for this first one. It's just a combination reaction. None of these other things apply. So that's pretty straightforward. For the next one, I've got KClO3 solid decomposing. It's breaking into two different pieces. So this is what we call a decomposition. So combination, sort of the opposite, is decomposition. And again, none of the other things really apply. We'll get to some other situations when they do, but for now, that's all it's going to be. So the next one, I've got KBr aqueous plus silver nitrate aqueous is going to potassium nitrate aqueous and then silver bromide solid. This is what we call a precipitation reaction. So this reaction here, we're going from aqueous things to a solid. So when you mix these two things together, it'll all be aqueous, but when you mix it together and you get a solid, that's a precipitation reaction. This is also called a double replacement reaction. So this is the first time that we see this, check all that apply thing. Anytime you have a precipitation reaction, you're going to be double replacement. So those two things are going to go hand in hand, basically. The next one here, again, we've got aqueous goes to aqueous solid. That's a precipitation. Precipitation means a solid is forming. So aqueous going to aqueous solid, precipitation reaction. All right, let's do one more example. So over here, this first one, we've got sodium hydroxide plus HBRO aqueous goes to sodium BRO aqueous plus H2O liquid. So it's not a precipitation reaction. It seems similar to a precipitation reaction because we're sort of switching things around, but we're not forming a solid. Precipitation means that we would have to form a solid. The fact that we're forming water is telling me that this is an acid-base reaction. So acid-base reactions are commonly, not always, but most often, they're going to be forming water as one of the products. When you take acid and a base, usually that's going to be OH minus plus H plus. That's going to give you H2O. That's a neutralization of acid. So you've probably heard of or actually done some neutralization reactions where you mix an acid and a base. This is really what's going on. This is why it's getting neutralized. This OH minus and H plus are getting neutralized to form water. That's a acid-base reaction. This also classifies as a double replacement reaction. So again, these are going to go hand in hand. So anytime we've got precipitation, that's going to be double replacement. Anytime we have acid-base, that's also going to be double replacement. Okay, K solid plus Br2 liquid goes to KBr combination. Pretty clearly, we're combining those two things to form here this new KBr solid. Here, we're doing a decomposition. So these two things are, or this solid magnesium carbonate is breaking into the two separate pieces, decomposing. And then the last one here, we've got, again, another precipitation reaction. So in these examples, I actually didn't get a combustion reaction, so I'll talk about that in a second. But this last one, precipitation, aqueous goes to aqueous solid. That tells us it's precipitation. A combustion reaction is going to be where I've got O2. So if I've got something that's reacting with O2, that's going to be a combustion reaction. So combustion reactions are going to be where you burn something, and it basically it means burning in oxygen. So if you see oxygen as one of your reactants, most likely that's going to be a combustion reaction. And we'll start to recognize those as well. All right, hope that helps.